Let a, b, and c be the roots of the polynomial f of x is equal to x cubed minus 2x squared plus 7x minus 5. Find the value of the quantity a plus 1 over a times b plus 1 over b times c plus 1 over c. Okay, so first of all, we can rewrite this whole product as, well, this factor, a plus 1 over a, can be rewritten as a squared plus 1 over a. The second factor, b plus 1 over b, can be rewritten as b squared plus 1 over b. This third factor over here, c plus 1 over c, can be rewritten as c squared plus 1 over c. Right, and you can rewrite this as a squared plus 1, b squared plus 1, c squared plus 1 over abc. And the first thing you can do is notice that Vieta's formulas would give ABC is equal to, since this is a cubic equation, ABC is equal to this positive 5, right? So this is equal to a squared plus 1 times b squared plus 1 plus c squared times c squared plus 1 over 5. And at this point, you might be tempted to expand the numerator out into a huge bash involving a lot of Vieta's formulas, but let's stop for a moment and look back at this polynomial. What does this f of x mean? Well, f of x can also be written as not just this x cubed minus 2x squared thing. It can also be rewritten as x minus a times x minus b times x minus c, because a, b, and c are the roots. So no matter if a, b, and c are complex, you can always write f of x like this. Okay, and what good does that do? The next thing you can realize is that, well, x doesn't have to be a real number. You can plug in, for example, x equals I, and you get f of I is equal to I minus a times I minus b times I minus c, right? And f of negative I, for instance, is equal to negative I minus a times negative I minus b times negative I minus c. And why don't we just multiply these two together? Because what we're going to get is we're going to get a really nice difference of squares. So f of I times f of negative I is equal to I minus a times negative I minus a times I minus b times negative I minus b times I minus c times negative I minus c. And what do we get? But when you multiply all this stuff out, you're going to get negative I squared plus ai minus ai plus a squared. And I squared is negative 1. So this thing just turns into a nice and easy a squared plus 1. And you can probably see where this is going by now. I minus b times negative I minus b is b squared plus 1. I minus c times negative I minus c is equal to c squared plus 1. So you get that this numerator over here is equal to f of I times f of negative I. So we just need to find f of I and f of negative I, and we're home free because we can just divide that by 5, and that's going to give us this quantity. Okay, so now look at f of x is equal to x cubed minus 2x squared plus 7x minus 5. And what we do is we just go ahead and plug I into this. F of I is going to be I cubed minus 2I squared plus 7I minus 5. And I cubed is going to be negative I, right? Because I squared is negative 1. So negative I plus 2 plus 7I minus 5. This is going to be equal to negative 3 plus 6I. And f of negative I, you can just plug negative I in. Negative I cubed is equal to positive I. That's negative I cubed minus, well, 2 times negative I squared is going to be plus 2 again, plus 7 times negative I, which is going to be a minus 7I, minus 5 again. And we're going to be left with our negative 3 minus 6I. So f of I is negative 3 plus 6I. F of negative I is negative 3 minus 6I. So we can just multiply them together and we get a really nice difference of squares. You get 9 minus 36i squared. This is equal to 45. So f of I times f of negative I is going to be 45 over 5. And that is going to be equal to 9. So we are done. Thanks for watching, and I will see you next time.